So thank you to everyone for joining today's LF Decentralized Trust meetup. We have a topic today around how flexblock.io and Besu are making enterprise blockchain a reality. Again, if you have any questions, comments, or thoughts during the event, please feel free to type in the Zoom chat, and we're happy to have your input. And with that, please take it away.
Thank you. Mike, would you be starting off?
Yes, Srini. Sure, I'll just go ahead with that. First of all, very good morning to everyone present. I am Mayank from Innoflexion Technology, a product engineering firm with over a decade of experience in developing cutting-edge technology solutions. And with me today is my co-founder, Srini, and our senior blockchain developer, Meenakshi. And we are really excited to walk you through our initiative FlexBlock, an enterprise grade blockchain as a service platform powered by Hyperledger Besu. So before we dive in to the architecture, I'd like to set the stage for why we built FlexBlock and what problem it solves. So I would like Srini to go ahead and give his views on that.
Okay. Can you move to the slide? I
Yeah.
think it's not moved. Okay. So I think most of us are working on blockchain, and we understand the complexities of it. But if we look at the market data, one of the data says that close to about 90% of blockchain projects in the enterprise space um, end up in failure, and the lifespan of a typical project that once if even if it goes live is about a little over a year. And if you look at it, the reasons behind these failures and why the traction has been slow on the enterprise side, one, there's high complexity, it's a high cost, there's a expertise gap. Your typical web developer is not going to cut it. And then there's infrastructure challenges, right? So you got to set up a network, you got to maintain it, you got to make sure your patches are in and so on and so forth, and whatever layer one blockchain that you got. And then if you get through past all of that, there's interoperability of the chains, and how do you leverage it in the typical enterprise space with your ERPs, your CRMs, and the other cloud offerings, and maybe even the AI platforms that you have. Net result, I think most projects don't scale beyond the piloting phase, or at best, they are serving a very minimal functionality within the enterprise. So we wanted to solve that. We wanted to make that more, easy to use, um, and more simple for enterprises to use, and something that a typical web developer could start leveraging, right? Think of, we wanted to do what Stripe did for payment gateways, right? If you dial back 10 years ago, people were building their own payment gateways and going through all the PCI compliance and whatnot, right? So, and today, no one even attempts to do any of those. So that's what we wanted to, kind of do in the blockchain space for enterprises. And and we thought, why not leverage the typical SaaS offerings that the other products have, and convert, why not leverage the blockchain as a service approach, right? So, Mike, you want to go to the next slide?
Yeah.
So with blockchain as a service, you get to take away all the infrastructure complexities that come with it. You can it's a rapid deployment, ready to use blockchain environments. There are no manual setups, so you just expose the APIs and get working, right? So it allows you to scale. If you have the identity management also attached with it, you can leverage your SAML integrations along with it. So basically allows you to focus on the business problem right? And you're able to scale, right? That's the that's the premise that we went with, and then we went. We started to build this product along with. Initially, we started in partnership with SK of Korea, and then we have taken it forward. They're still kind of backing this platform. Um, Go on to the next slide, please. So you want to take the slide? You want me to go ahead? Ryan?
Sure, I'll do that, Srini. So thank you so much, Srini, for your explanation for the first two slides. So we are truly a plug and play blockchain. You can deploy on-prem or cloud networks in minutes, not months, and it scales automatically. And it's how we abstract complexity by providing vertical stacks, letting you focus entirely on your business verticals. Basically, this is all exposed via rich APIs and SDKs that feel just like Web 2.0 development. This allows for seamless integrations with all your critical enterprise systems like ERP, CRMs. Plus, we are built for enterprise grade reliability and performance, capable of about 600 transactions per second with response times under 15 milliseconds. So this would be our FlexBlock framework, where I would like to invite our senior blockchain developer, Meenakshi, to go ahead and explain it because she would be the perfect person to walk us through this. Meenakshi, all over to you.
Yeah, thank you, Mayank. Hello, everyone. Let me walk you through the FlexBlock framework and how it simplifies blockchain integration for enterprises as well as for developers. So, FlexBlock is built with the three-layered architecture designed to separate concerns, ensure scalability, as well as provide a seamless developer experience. If we look at layer one, this is our foundation. At this layer, FlexBlock leveraged Hyperledger Besu, which gave us deterministic consensus, EVM compatibility, as well as on-chain state management infrastructure. On top of that, we have enhanced Besu with managed testnet as well as mainnet environments, which provides a robust and trusted foundation for all blockchain operations and application development. Next, we have layer 2, which is the core API layer, and this is the heart of FlexBlock. This layer is all about developer productivity. It combines both utility APIs as well as solution APIs in order to simplify blockchain development. Sorry. Um, let's go through utility API. Um, Generally, managing nodes, logs, block explorers, and user accounts could be tedious. But these APIs provide teams with complete visibility, control, and governance over the network, with significantly reduced operational efforts. Parallelly, we have developed solution APIs, which are designed with developers in mind. So traditionally, what happened in order to build decentralized application, it involves using front-end frameworks like React.js combined with Web3.js, requiring developers to manage private keys, estimate gas, sign transactions, and coordinate RPC calls. This approach was time-consuming, error-prone, as well as it demanded deep Web3 expertise, which was difficult for most of the developers. FlexBlock removed this friction. Through our REST APIs, developers can easily work with decentralized identifiers, smart contracts, and document and data management as well. FlexBlock on FlexBlock, our tokenization module leverages ERC20 for fungible tokens, ERC721 for non-fungible, that is NFTs, as well as ERC11554 for hybrid tokens, allowing developers to create and manage any kind of digital asset with ease. Um, so behind the scenes, we have Node.js backend, which manages user authentication as well as securely signed transactions using a wrapped Web3.js layer to simplify blockchain integrations. This specific setup allowed developers to rapidly build sector-specific applications, whether in EV or battery, healthcare, as well as supply chain, without deep blockchain expertise. Now let's move to layer 3, the API management layer. Here, this layer acts as the integration as well as governance bridge between solution as well as utility APIs. It provides secure authentication request routing, load balancing, as well as rate limiting and analytics, ensuring APIs are reliable, secure, and scalable across enterprise systems. Finally, we have FlexBlock supports flexible deployment models as well. Enterprises can deploy on-premises or on major cloud providers like AWS, Azure, or GCP, giving full control, scalability, and production-grade reliability. This concludes the overview of FlexBlock's architecture as well as deployment. I'll hand over to Mayank so that he can walk you through the next set of slides.
Thank you so much, Meenakshi. That was really informational. And now moving on to the next slide, as we've all heard that we are using Hyperledger Besu. So you all might be thinking that why only Besu for FlexBlock? Why not something else? So why did we choose Hyperledger Besu as the backbone? It's very simple. Besu is EVM compatible and enterprise ready. And for this, I would like Srini to go ahead and walk us through that why we have only chosen Besu for FlexBlock.
So a couple of reasons here. I think one is, as I mentioned earlier, going back to the problem that we were trying to solve, we wanted it to be able to have the SaaS, kind of a feel when you're working with this. And I think Besu kind of naturally extended that ability to take that and convert it into a SaaS application. And that's number one reason. But besides that, I think there is EVM compatibility. So if there is, if you're working with, that gives it, brings in a lot of the folks who have done the typical crypto work into the fold. So you can leverage those expertise into, from a development perspective, the customer has. Also, the compatibility to work with public chains, so that allows it, and also the ability to migrate from one. If a customer is already leveraging Ethereum for something else, you have or Solidity contracts for something else, you can port them to our platform or to port them to Peso. That's easy. So those are the reasons, and then any of the dApps that have been developed, they can be leveraged on this platform. So the whole lot of seamless EVM compatibility reasons was the number one choice, I would say. And besides that, the enterprise grade readiness was one of the key reasons why we wanted to choose this platform. And also from a licensing standpoint, it is an Apache 2.0. So that allows for enterprise deployments, and as well as in the consortium environment, Besu enables fine-grained access control of networks and ability to control who's writing to the blockchain and who's reading off the blockchain. So those are the main reasons, I would say, at a very high level. And also, from all the other reasons from a healthcare perspective, it supports the needs of HIPAA and things of that nature if you want to implement that. So that's in a nutshell why we chose Besu, and obviously a great community here that we leverage upon when we had issues and things of that nature. So all in all, it's been a great choice for us.
I really like that, Srini, that using Besu for flex block, like most of us have that one question in mind, that what the product that we are choosing for our organization, especially in terms of infrastructure, which will be handling a lot of data, which is very important for the organization. It should be compliant, like it should be regulatory ready. So it means like basically it supports things like HIPAA, PHI safe, data sharing, and regulatory compliance out of the box. So with that, we are moving to our next slide. We have talked a lot about compliances here. So, speaking of compliance, FlexBlock is designed to solve real world industry problems. We support critical use cases across various sectors. First one would be the most important one, which is right now every SaaS and BaaS platforms are targeting, that is healthcare and pharma. So, for traceability and auditing of genetic samples in clinical studies, securing patient data, and automated regulatory compliance, which is the most important part for any healthcare or any biobank or any biotech organization. Keeping that in mind, Hyperledger Besu with FlexBlock would be the right choice. Apart from that, when we come to responsible AI, training data provenance, lineage of AI model for establishing training data, and decision attribution as well. Then we come into the fintech sector where uh, it can help in fraud prevention, in terms of caching business, in terms of auditing also for digital assets and transactions. And the most important would be the tokenizing of the reward program. And then moving on to the manufacturing, which also includes the companies or the organizations who are also going ahead and doing their part in the EV management. As we all here know that today the world is moving towards green energy. So for that as well, it is the best because it goes ahead and checks the battery life and the warranty management for the EV, for the decentralized ID and the credential verification, and also the carbon credits and the supply chain traceability, and also the audit trail. Now, as this would be very new for us, so I would like Srini, can you explain us that what does carbon credits exactly mean?
So I think just to take a step back here, these are basically suite of APIs that are built for each of those in industry verticals. So we have those suite of APIs. I mean, I think our richest suite is for the in the healthcare and in the biotech space. So where we are able to offer various traceability use cases. So biobanks can just leverage out of the box our suite of APIs. Pharma companies can use our suite of APIs and get the blockchain traceability going. So these are, I would say, industry verticalized solutions that we have, and I think I just want to highlight the responsible AI. And today we are all struggling with, we're seeing a lot of discussion going on, how did a model get trained and where did the data get sourced? Was it ethically sourced? And do we really have visibility in how a data model was trained? I think blockchain is a great solution for that, and we basically have opened up a suite of APIs for that. So if someone is fine-tuning their model, they can just instrument the code with FlexBlock to be able to provide that traceability to whoever is consuming the model. Gives them a lot of confidence on using a particular data model. Likewise, when AI is making a decision, so to be able to implement explainable AI, if you want to attribute the decision of a model, that also can be instrumented within your code. To answer your question regarding the carbon credits, I think where we have exposed that is with one of our, it was actually built for one of our beta customers, where they're sourcing a lot of raw materials. There go in between the the vendor and the purchaser of raw materials, and carbon credits was something that needed to be tracked for in that use case. So basically, the vendor who's supplying is opening up their energy consumption patterns, their shipping, cost and energy consumption. Likewise, on the purchaser side. So all this information gets onto the blockchain. So if anyone wants to have a credible information about the whole carbon credit, and you want to get carbon, set-offs, so the blockchain is a way where it's tracing all the way from the mines all the way um, into the plant where it's getting consumed of the raw material. So that's where our platform has the capability to do the traceability. And again, these are suite of APIs for these industry verticals that can be leveraged. I think we can go on to the next slide.
Thank you so much, Srini, for that. I'll go ahead and walk you through one of our use cases. But before that, I would like, if anybody has any questions in their mind, we are open to answer.
Hello. Scheduler of Alfred Hudson Jr., transportation clerk and assistant.
Yeah, I think there's a lot of background noise, Hudson. Maybe we could take a question on the chat.
Yeah, I muted that person. Yeah, if the person had a question, I would suggest put it in chat.
Okay. I think, Mike, we can go ahead with the use
Sure.
case.
Sure, you can definitely go ahead and post the question in the chat, and we'll be very happy to answer that. And moving on to the next slide, which is most probably the one of the use cases that we are solving in terms of the biotech, would be traceability for genetic samples and clinical study. So to make this more easier, let's walk through this healthcare use case. Like, the journey starts with the patient details and the creation of a patient DID, which is secured as block one, everywhere you can see on the chain. And the clinics then collect samples, set up serial numbers, and move to vial tokenizations, creating the block two. This ensures every physical sample is represented by a unique, traceable digital asset on the chain. Then the research center can request a transfer, and the system manages the approval process. Finally, in clinical trials, the asset is tracked as block 3 for things like partial wild draws and testing, ensuring a complete immutable audit trial for all parties, including the regulator. So, Srini, would you like to add anything in that if I missed?
Yeah, so in this, I think what I think we will see the video of this whole thing. This was
Yeah.
developed in partnership with Callum. So they're one of the partners for us. So the use case, just to a little bit give you the business aspects of this. So typically, if a patient can actually donate his genetic sample for research in this scenario, and that goes into a biobank, and then there are these research facilities that are requesting this sample. So, and Callum is based in Europe, and their regulation in terms of this whole handling of the genetic sample is very, very rigid. And they need to start right from the consent of the patient all the way till the last vial is consumed, right? So each time, if I donate 100 ml of my blood for genetic research, and if the first research firm consumes 10 ml, right, the whole 100 ml, I mean 10 tubes of 10 ml goes to the first research center, and then they consume 10 ml and they send back the rest of the 90 ml, right? So that's that's the regulatory environment that they operate in. And each each transaction as a physical movement needs to be recorded as a transaction onto the blockchain, and the regulators need to have a view. on the date, time, and when did it leave the facility, when did it go back, whole bunch of things there. So that's where this was implemented, and we have the suite of APIs to enable that. So I think we'll go through this video here that Mike has, and I think that
Yep.
will illustrate this use case much better.
I'll just go ahead and present this video before you. Just give me a moment. So I'll just go ahead and leave you guys to enjoy this short video that we have to see basically FlexBlock in action. I'll gonna play it.
Mike, we can't hear the audio.
Yeah.
Examples in biotech research is a complex task. Inaccurate records, missing files, and poor communication often cause delays, higher costs, and risks to research integrity. Regulatory requirements for data integrity and traceability add complexity in the biotech industry. While Callum identified blockchain as the solution, the technical complexity, infrastructure demands, and high costs presented significant challenges. Partnering with FlexBlock enabled frictionless blockchain adoption. FlexBlock's blockchain as a service platform with its pre-built frameworks offered a seamless solution for Callum. The solution enables immutable recording of file history from collection to analysis. The solution ensures data integrity by using decentralized storage, preventing any unauthorized changes. It also provides seamless cross-study traceability, effortlessly tracking files shared between studies or project leaders. Moreover, blockchain guarantees regulatory compliance by automatically creating an auditable trail for every action. The result? A transparent, secure, and efficient system that drives collaboration and trust. The platform currently has two personas, a project leader who creates studies and makes file requests, and a sample management center, which keeps an inventory of the files and fulfills file requests from project leaders. Let's see how the platform works for a sample management bank. The collected tab groups files by sample, allowing users to view file details, enrich data from the project leader, and summaries. Key patient information captured during sample collection is also displayed. The requested tab displays incoming requests from project leaders. Filters help narrow down files based on study requirements, and selected files can be dispatched with a single click. Once dispatched, requests move to the Dispatch tab and upon delivery to the Delivered tab, where file status and usage updates can be tracked. The user is also able to view every single file transaction that's recorded on the blockchain through the blockchain events screen. Now, let's explore the project leader portal. The dashboard provides key project statistics and a project list. Project leaders can create new projects by entering details like the pathology being studied. The project details section allows leaders to update and manage project information, keeping all relevant data organized and accessible. Requests for specific files can be made from this portal, narrowing down samples with tailored filters and optional details. The Receive tab shows delivered files, allowing leaders to confirm their condition and mark them for use. Details include data filled in by the Sample Management Center and enriched sample data from other files in the same sample. Files from the same sample, even when split across multiple studies or leaders, are linked here. Blockchain ensures every interaction is recorded and verifiable. With FlexBlock at its core, Callum empowers researchers, streamlines operations, and builds trust for the future of pharmaceutical research, all while ensuring data privacy, sovereignty, and locality. This demo is brought.
So So, so this was a short demo from our site showcasing one of our use cases. I'll just go ahead and present the screen 1 minute. So, thank you again for joining us. We believe FlexBlock is a solution that helps move enterprise blockchain past the pilot phase and into full production. Now, I'll go ahead and pass it on to Srini so he can go ahead and answer all your questions if you have.
So we have the link for the API documentation. So if you guys want to explore it, those are available. If you want to play around, we could set up a sandbox for you to try out your use cases there. It's fairly easy to do it. You can get your in fact, if you want to deploy your own chain, we could do that in under 30 minutes, your own environment as well. So yeah, that's in a nutshell what FlexBlock is. And um, if there are any questions, I can take them. Um, so the question is, I'll go with the first question here. Um, I'll probably just take the relevant ones. Do the APIs run in a container such as Docker? Yes, you can run them, and we are cloud agnostic, so you could include them into the containers. That's the thing I posted the answer there. Can you briefly describe the encryption method used for the API transactions, in particular the public Ethereum blockchain interface? Is it only private public keys with digital signatures? Um, so I think we we have the all the J, with the typical Web 2.0 tokens, they are JWT compliant, and then we are hosted inside. Yes, it's a public private key kind of um, setup that you have there. So yes, the answer is yes. Meenakshi, if you want to add anything to that question, feel free to.
Yes, Rini. So, since we have leveraged Hyperledger Besu and the public Ethereum interface, it's primarily relies on asymmetric cryptography using both public and private key pairs, where private key of the user will be used for digital signature in order the transaction takes place successfully.
Okay. Any other questions? Okay. David, back to you.
Well, great. If there is nothing else to share and no other questions, then thank you everybody for joining. I will send a link around to everybody who signed up with the recording, so you'll be able to watch. And then if you could share the slides, I'll send those around as well. So thanks, everyone.
I think there's one last
Oh,
question. Any option to try FlexBlock? Yes, I think we have sandboxes. I think you can reach out to Mayank. He can set you up with the sandbox for you to try. Yes.
great. Any other last questions?
Thank you.
Great. Thanks, everyone.
Bye-bye.
Thank you, everyone. Thank you, David.